Okay, good morning, everybody. Today is January 11th, 2021 already. Crazy. But so as we have been working on some proofs, last week we did parallel lines cut by a transversal. Helps us think about angles and how to prove their congruency. Well, this week we're going to continue to work on proofs, and we're going to start out with triangle congruence theorem. So the first thing that you need to know is what we've talked about previously are the different triangle congruence theorems. First one here in the box says when two triangles have three corresponding sets of sides congruent, use SSS to say the triangles are congruent. So as you can see in the diagram, the 2 marks, 2 marks, 1 mark, 1 mark, and 3 and 3. So this specific theorem is called side theorem because all three sides are the same, SSS. Okay. Second one that they have listed here is when you have a side, an angle, and a side. So this would be, you guessed it, SAS. Okay, notice the order in which these go in. Okay, it's important. So you have side, angle, oops, got my height or my dash there. Side, angle, side. Okay. And they have to be connected in that order. So side is connected to the angle, which is connected to the other side. So it goes in that order, right? It can't be up here in the gap, okay? When two triangles have two pairs of congruent and angles congruent, and the sides between them are congruent, use ASA. So again, notice the order, angle, side, angle. So angle, side, angle. Okay, when two triangles have two pairs of angles that are congruent, and the sides not between them are congruent, use angle, angle, side. So again, you have angle connected to an angle connected to the side. Okay, notice the side is not in between, right? And it's not over here. It is angle, angle, side. All right. Okay, and lastly, you have when two right triangles have congruent hypotenuses and a pair of congruent legs, use hypotenuse leg. So this one's nice. So anytime that you see a right triangle, if it has both the hypotenuse and leg, you don't have to worry about the other angles. So hypotenuse leg, or I'm sorry, yeah, the hypotenuse and leg, when they are congruent to each other, we call this HL, or hypotenuse leg. Okay? All right. There's some other properties as well. We've talked about a couple of these. The first one here being, of course, that you have reflexive property, which basically says that triangle ABC is congruent to triangle ABC. Right? So like this triangle is congruent to itself, basically. Okay, then you have symmetric. All right, symmetric states that if triangle ABC is congruent to triangle ABD, then it must also be the same case the other way around. So then triangle ABD has to be congruent to triangle ABC. Okay. All right. And then transitive property says that if triangle ABC is congruent to triangle DEF, okay, and triangle DEF is congruent to triangle JKL, then because like if this one's congruent to this one and this one's congruent to this one, then this one must also be congruent to the last one. So then triangle ABC must also be congruent to triangle JKL. Okay, that's how transitive property works. We've talked about that a couple times already. Okay, so there's your reflexive, symmetric, transitive, as well as all of your congruence theorems for triangles. So now at this point, let's put them together. Let's work through a couple proofs here. So number one, prove that the following triangles are congruent. All right, so always state your given first. Okay, so in this one, let's see. They give us that angle M and angle P are congruent. And angle, I should label these a little bit better, huh? Let's see, so NMQ, angle NMQ is congruent to angle NPQ. And they also give us that PNQ, so this one is congruent to this one. So PNQ is congruent to MNQ. Okay, so those are the two things they give us. Then, okay, we can say that this line is congruent to itself no matter what because it's the same line. So for either triangle, it should be the same size. So line NQ is congruent to line NQ, which means that this is reflexive property. Okay, and so now we have a congruent triangle because we have angle, angle, and a connected side. So now triangle, let's see, M and Q is congruent to triangle P and Q because of angle, angle, side. You don't really need the last box. So what you could have done is listed two different given boxes. Like this is one given, this is the second given, so you could have done it in the second line. You don't really need to though. Okay, next proof, same thing. What do they give us? Well, they give us that AD and BC are congruent. So AD is congruent to BC, and AB is congruent to DC. Okay, and that's given because of the little marks. Okay, then we also know that any line used in two separate triangles is the same line by reflexive property. So DB is congruent to DB because of reflexive. All right, so that means that we have a let's see, side, side, side. So triangle A, let's see, gotta go in the right order here. So A, B, D is congruent to triangle C, DB. Okay, so you had to go 2, line on the 2, and then hypotenuse, so 2 and then hypotenuse. Okay, and we know that because, as we just stated, of side, side, side. Okay, so going right along here. All right, so again, prove the parts and try and figure out what you can use. Once you've proven that two triangles are congruent, you can use the CPC-TC, which you probably remember from GAC 1. Corresponding parts of congruent triangles are congruent to prove that very specific angles are congruent to each other. Right? So in this one, angle B is congruent to angle E. So it wants you to prove that this angle is congruent to this one, actually, is what they want. I'm sorry. So this should be angle F, not E. F. Change that to angle F. Okay? All right. So first of all, let's prove that the triangles are congruent. Then we can prove that their parts are congruent. So what's given to us? Well, it's given that we have two legs and an angle in between that are congruent. So that would be side, angle, side. So we need to prove, let's see. First of all, statement, BC is congruent to EF. Okay. Angle C is congruent to angle E, and AC is congruent to DE. Okay, so those are all given. Those parts of the triangle are all given. Okay, well, again, we can now say deliberately that ABD, or ABC, triangle ABC, is congruent to triangle ADFE. Okay, and we know that because of, as we just stated, side angle side. So now, because we know that, we can say that angle B is congruent to angle F because of CPCTC. Corresponding parts of congruent triangles are congruent. So since we knew it went this way and this one goes this way, we know that those have to be the same. Okay? All right. So a couple more examples here. What is the theorem that would state the two triangles are congruent? Is there or is there not enough information? So in part A, let's see, side with an angle between and then another side, side, angle, side. So that would be side, angle, side. This one has an angle and a side, okay, but we don't have anything else from a triangle congruence, right? So this would be not enough information. Okay. And then we have the next one, which is side, 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 side. And then the last one, which is angle, side, side. Ooh, that's not one up top because think about what I just said. So that one is also not enough information. Okay, you can't use that one. All right, so your homework tonight is to complete these practice examples right here. I already did these ones for you. Shouldn't have. My bad. But your homework is going to be to complete these 4 examples, and then also to go ahead and put these statements and reasons down below. Okay.